Hello, hi. Welcome to Deep Realm channel. This is Siddharth. Today I want to go through a specific paper talking about retrieval augmented generation system in the specific LLMs models. Let's dive straight in. For this, I have designed a specific HTML which speaking about this specific thing, what it does and how it performs, and what are the issues and what issues that it came up. And everything, whatever in this paper, I summarized in specific HTML text starting from here. As usual, before we start explaining or going through this paper, let's discuss about what are the prerequisites you should at least know about this paper. For this, the specific prerequisites concepts are you should understand about what is RAG. The RAG is retrieval augmented generation is just an approach. What it specifically does, it will be specifically used in the LLM models by integrating the external source of knowledge and retrieving it and generating a text based on that external knowledge. In this RAG, there is a specific workflow, how you can see it. The first basic thing is when a person submits a user query, whatever the query that is being submitted, it will be under processing. It will divide into text, subtext, a branch of text and everything. Based on the text that it provided, it will retrieve a specific documents that are near to this query processing request. And from that, it will create a context integration where it will only retrieve the information that is nearly semantic to our user query. And once that is done, the main basic thing is to generate a response for the user whoever submitted the query. It will try to gather that all that information and it produces that response and generate it. This is all about the RAG on the high level, a specific workflow. And the main components in this RAG are only two, the retriever and generator. As I told you, whenever the user submits a specific query, it receives a relevant information and it gains that knowledge base from the external data source and it retrieves typically using in this vector embeddings. For now, remember that embeddings is just a numerical representation of a particular numbers like in the float values about a specific word, group of text, a para or something like that. So it will try to get that specific text that belongs to that user query and it will retrieve all the information. For now, we can call this as a semantic similarity. Semantic similarity is nothing but a specific meaning that is similar which we can find that information in the particular documents. Basically, if you understand, it's a basic common sense. You will try to retrieve some information from the external source. You will try to mimic in such a way based on the query. You will create a content that will be used for the user and you will try to give that concise information and the appropriate response to enhance or to make the user understand based on the query. Next, we know we are going through this RAG. This RAG model is applied on the several large language models, network based. This AI system, whatever we have it, it's a neural network based. It should be trained on a massive data to learn specific patterns, maybe about the language, relationships, or about the specific criteria and finding out the patterns from it. These models technically usually use a specific architecture called transformer, which I will try to get that in the next class detailedly. The transformer is a deep learning model where it will try to find the patterns and get a specific retrieval of information, right? And whenever a user submits a query, it allows to process them and it generates a text by understanding the context of the user query. That's what it does. Now, we have several characteristics on the large language models. The one of the major ones are scale. As these models are getting smarter and smarter, behind the scenes, these have to be trained by an enormous size of data. Usually we call it as a tokens or the parameters, and it is being trained on even a billion or trillions of the parameters. And there is always two phase of the training process for this LLMs also. For this specifically, The first thing is the pre-training, where it will understand the language, it will get trained based on the data and generate some patterns, and we'll also fine tune that specific model based on the specific task. And next one, the major thing is about context understanding also. You need to have an ability to maintain and utilize the context across the thousands of tokens. The other thing is the zero or few shot learning. This is one kind of strategy where zero shot is without any training. You are using that model with a minimal experience, and few shot learning is with a minimal experience or minimal training model. And there are several lot of limitations and problems in the LLMs. And the one of the major thing is hallucinations. So what happens is whenever you ask a question, some of the LLMs will provide an answer with so confidence that it looks like correct, but on behind the scenes it is wrong. If the model has been trained maybe last week or previous month or previous year, whenever you are requesting something of your question, a specific answer, maybe the data may be pale, has been not new and up to the mark, because every training model will have its cutoff date. And there may be some problems also where the model is not trained on the specific knowledge. So whenever you ask the questions, you may not get the answers whatever you are expecting. And context window limitation, this is also a normal problem, because sometimes whatever the context or a query you can ask, maybe it's of 1000 words or 2000 words or 3000 words, but behind the scenes the model can only chunk it and only have that specific window of taking 100 words, process it, 200 words, 300 words, and goes on the sequence to process it, where you will or you may get the information that is not what you are expecting. And before going to the paper, let's also see, because since this paper is all about text chunking methods, let's see some of the text chunking methods here. So I try to have a graph displayed here. We have several text chunking methods, and each method, how much it's been effective and how much it can provide correct results based on the chunking and what is a retrieval of the answer for us. So if you see here, we have several types of text chunking methods like fixed length, delimiter based, sentence paragraph, embeddings based, topic modeling, LLM based, and also MoC framework. If you see this MoC framework, this is the specific one we will talk in this particular paper. But before that, let's see what is the effectiveness. In the fixed length, if you see out of 100, the score is just 40. And next they have upgraded to have something called delimiter based, something like for each paragraph or sentence, you may see like a single quote or a full stop or exclamation, everything. It will try to cut that based on the delimiter, and it will have that context window ready, and it will provide the results backend. And the third one is sentence or paragraph, because the delimiter based is giving some wrong answers. It's the model, they are also preparing with a sentence or paragraph picking. If you see this sequence, as there is a new text chunking method, they are trying to improve its effectiveness from starting from 40, and wherever we'll talk about this MoC, it has been reached to 90. And next they have come up with this embeddings based, which I said it's a text represented in the numerical format, in a float format. And there is also called the topic modeling, which is about picking a specific topic and try to get the retrieval from it. And also the next one is LLM based. Using these pre-existed LLMs also, you can ask a specific text to be chunked, and based on that the score was very high, it is 85. But even after that, in this paper they're specifically talking about this MoC framework, which we'll go through in a second. This came up to 90% out of 100% about its effectiveness, right? And if you see there, if you see these chunking methods, we can divide into a specific levels. In the first one, it's a traditional text chunking. If you see here, the name itself speaks, it's a fixed length chunking. Delimiter means it by delimiter, it will specifically divide those into paragraphs, a sections, and sentence or paragraph. It just creates a chunks or divides the big text in the form of sentence or paragraph boundaries. And there is another group which is called a semantic chunking. Usually you have a lot of chunking methods in this. The main ones are embedding, basing, chunking, and topic modeling approaches. This specifically uses sentence embeddings. Embeddings is nothing but behind the scenes. If I'm saying a particular question or asking a particular question, it tried to find a identical similar text that's present in the backend so that it can retrieve it properly. And topic modeling approaches, same thing, identifies a topic and it tries to shift into the coherent chunks that have a better meaning than these traditional text chunking methods. And the final one you can see here is advanced chunking methods. In the advanced chunking methods, usually they use this LLM based approaching. Specifically, they give this specific test and they'll have this logical boundaries in the text and they'll try to divide it, and it will perform way better than the semantic chunking and traditional chunking. And there are several hybrid approaches also. Usually it's a different chunking strategies on the specific level of granularity to provide a better result and better response. Now, on the other side also, if you see, the one of the major system here in this RAG is retrieval, right? It's mainly used for the question and answering. So this dense retrieval is just an approach, right? It will basically use this vector representations based on the query. You find a document to find the relevant information. Unlike this specific retrieval methods, like you'll only go by the keyword matching, you may get the answer, but it won't be that much perfect. Using this dense retrieval, it tries to find in that vector and find the relevant information or the documents, right, which exactly or nearly match this query. How this dense retrieval works, there are several steps in it. The first basic thing, as I said, is whatever the documents you have here, you will store in a vector representation. That's the basic thing we needed. And whenever you're creating some data or whenever you're converting this into specific format, you need to have some database. For this, we will be using this vector database. And after that, and the encoding, right? Once it is ready, you will have this query encoding. So whenever the user questions, they are encoded in the same vector space how this particular text is created in this vector database, so that whenever you're trying to do this similarity search, those embeddings are matching and it will try to get most similar words from the query embedding. That's a basic thing. And ranking and retrieval. And behind the scenes also, whenever you're trying to get a particular retrieval information, every specific retrieval information will give a rank, maybe 100, 99, 98, 97. Based on that, you may pick the highest rank, which is 100 or 99, 98, and from there you can even pre-process it if you want to do it, or you can get the latest rank information to produce to the customer or the client with a particular output. And we should also understand there is a several impact of text chunking on the dense retrieval, because the chunks sometimes may contain too large. For example, even I have 10,000 words or 5,000 words, even if you divide into a chunks, maybe there may be lot of chunks processed and each chunk may be of large text, right? In that case, it can't get that particular relevant information. Sometimes you may get also irrelevant ones. Sometimes maybe the chunks are too small and it won't understand what we are asking for. It may provide some hallucination or vague results. So poorly defined chunk boundaries can also split this related information across multiple chunks, and sometimes it will be very confusing also. And even you divide a particular text or rewriting or converting this text into the embeddings, which is a numerical representation, if the text chunks are not properly evaluated, the similarity search may also go wrong, and whatever the information you're trying to expect from it, it may not be right. This is all about the prerequisites. Now, let's understand what is this all paper about, what they are speaking specifically about this text chunking. And since we know in this world of artificial intelligence, we have several large language models, like for example, like a ChatGPT, right? It has shown a better and very good results like generating a human-like text. However, we also should remember they are facing several challenges on the hallucinations and this outdated knowledge and this limited context windows. This particular RAG system, whatever we are talking about, it aims to address these limitations. The main point is to retrieve the relevant information from the external responses, external sources, and also before generating these responses, it is also validated to check what information we are retrieving it from. And always in these LLMs, the implementation and also the attention is more on finding out what response we are getting into and what kind of text we are getting into. But the major one of the thing is this text chunking. Whatever we are trying to see in this paper, this is already been overlooked. This paper also introduced a specific framework called this mixture of chunkers, which is MoC, proved that it significantly improves the specific neglected part in the RAG system. And I also tried to generate a graph based on this paper to show you what is the research focus. And if you see in this blue colors, the query processing, the research focus is been nearly, like if you want to give a value, it's been like 70 out of 100. Document retrieval is very high because that is one of the way the future is going through. And the context integration, how you are getting the context and how you are integrating it and how you are providing the result. The research is on this module are also very high, and the response generation, which is one of the main necessity thing in the RAG, in the generation side also, the research has been focused on. But if you see in the text chunking side, there is no better or high research is been happening on this text chunking. So this paper talks about this particular problem. And what is the importance of text chunking? Why it is so important? Whenever user sends the query, after that a particular document has to be studied and understood. In the backend, this LLMs divide that text into small and a manageable pieces, right? Before they are stored in the retrieval system. The quality of these chunks directly impacts and how well the system can find the relevant information when answering the question. This paper identifies the weakest link in the RAG system, which is nothing but the text chunking, right? Even though you have advanced retrieval algorithms and powerful LLMs, if you don't have a better chunking model, it can severely impact the performance and also this response. This is because the chunking is one of the major part that determines what information is available and what should be retrieved first place in the basis of ranking, right? Why chunking matters? This is a major concept, right? Why it matters, right? Think about something. I have a library. In that library, there were a lot of books, and the information in that books are assembled wherever they want. Whenever you want to find that information, it quite impossible because it is not in a specific position, and it is also not a best search system. If you go by book or like even the information which is not in properly evaluated, it will take a lot of time. So whenever this chunking is very poor, the RAG system can also find the relevant information, but it is not up to the mark because each text chunk should have a relative meaning. If it is not able to divide the text into chunks with a specific meaning, there may be a chance of hallucination, and also you also miss the retrieval. It won't be up to the mark, and whatever you are expecting, that may be wrong. And let's understand what is this current chunking methods. As we know, like in the first session, we went through several chunking methods and their limitations. Here, we have like several groups like traditional rule-based methods and semantic chunking. Traditional rule-based, as we already went through, it just based on the specific delimiter length or a specific length to divide that particular big paragraph into a specific form of group of words or a paragraphs or the other structured elements, right? For this, the limitations is very big because it won't go by the similarity matching or the semantic relationship between the sentence. It is just cutting down the chunks based upon the length and also the delimiter, which may sometimes you miss the actual meaning behind the scenes. And creating these chunks may be highly variable because maybe this time it may be correct based on the language you have given and you have provided, the chunks may be divided in such a way that it won't find a similarity between the previous to the next. Then there will be issue of the response. And also after that, there have been several methods that came up, which is similarly called semantic chunking. What it usually does, the embeddings is the major concept that holds, which it tries to rewrite that information in the numerical representation where you can find a similar information based on this embeddings. And the one of the major thing is also is it may not capture the fine grained structure behind that what is that sentence means. So what happens here, even while you use this semantic chunking, there may be a high chance you won't get correct response, because whenever it is trying to find that particular information to retrieve from the documents, it can't get all the information that is required, or it may get unnecessary information which you won't be needed in your answer. And I've also created a graph based on this paper to understand on this rule-based chunking, semantic chunking, LLM-based and MoC framework. If you see, it's been divided into 5 boundaries. Let's keep that. The logical coherence, implementation simplicity, and also semantic understanding and computational efficiency. And the boundary precision, whenever you're dividing a specific text into group of words, paragraph, or whatnot. If you see this, if I click on this blue one, you see this implementation simplicity is on this, whatever you have the blue color, the rule based chunking, right? It is to the corner, which is very good on this one, implementation simplicity. Computational efficiency is also very good. And if you see, the lacking one is semantic understanding. Even the implementation is very simple and it is very computational efficiency, but the thing is, if it's not trying to understand the meaning of the sentence, it can't retrieve the proper information. Even it is simple, but you're trying not to get the actual results whatever you're expecting. The same way you can see in this diagram, the semantic chunking, which is of this pink color. If you see, it is in the all of the boundaries, but the thing is, it's not up to the mark. If you see, it's crossing nearly 70, 60, 70 something. And same way in the LLM based chunking, large language models are a little bit efficient or more efficient to understand a particular meaning. If you're passing your text through this particular language learning model, the semantic understanding would be very high. But you need to remember the computational efficiency is very low, because since it calculated as a tokens, it may take a lot of time. Each millisecond costs a money. If you see that, it will cost a lot of money. It is not that efficient, and the implementation won't be also that simple. And on this all this framework, the paper suggested this MoC framework. If you see the results here, in out of the all the boundaries, whatever you have, the logical ones, implementation simplicity and everything, it has crossed some of the benchmark from the previous methods, and proportionally it is nearly managing everything to this particular as a group. If you see this semantic understanding, it reached up to 80, and implementation simplicity is also good, 65, and the logical and the same way as a boundary precision, right? It is covering all the scenarios for to make a better understanding of a divided text chunk. This will help to divide this particular a group of big text into chunks properly and maintaining all this specific boundaries. Now, once they have designed this framework, they need to test it and they have to do this evaluation, right? This paper introduced 2 metrics for directly evaluating this chunking quality. One is the bounding, which is the boundary clarity, and also the chunk stickiness. If you see this here specifically, how beautiful is this is, it measures effectively how chunks are separated based on the specific meaning as a unit, right? It is also calculated using the meaning of the sentence sequences, if it's with and also the without context. So what happens here, whatever this bounding clarity you have it, the higher the value, the meaning means it is effectively separated. That is one of the metric. And the second one is also chunk stickiness, right? The major thing it's evaluating it is whatever the text that's being chunked, it has a semantic relationship between the next or the coming chunk, so that whenever you're sending this as a request to get a or to retrieve a documents that are matching to this, how much good they are. It is called chunk stickiness. And you should remember here, as the lower the values are, it means it is better independent, right? So it won't have that confusion. For example, I have a text chunk 1, text chunk 2. Text chunk 1 can have all the meaning without the requirement of the chunk 2 or chunk 3. In the same way, the text chunk 2 is also independent of text chunk 1 and text chunk 3, so that there won't be any confusion. Whenever you are sending this query, this framework will divide in such a way so that your retrieval percentage will be also very high and you won't be getting any biased information or irrelevant information. Now, if you see the performance according to this new metrics, right? There are different chunk methods as this limit index, llama index, and semantic chunking, Bloomberg chunker, and many things, right? And meta chunker, MoC. If you see specifically the blue color, which specifically talks about the boundary clarity, it is way high than all these methods. And also, you need to understand on this chunk stickiness, as low it is, as better it is. And you also see that it is lower than the other chunking methods. And the particular framework, how they have designed this framework, I feel this is one of the beautiful concept, and this is an innovative solution, right? It is divided into several components. The first basic thing is the common sense. By common sense, whenever you have given some text, it has to analyze that text, and it has to understand the in-depth meaning of the text to classify the granularity. And then it has to also select that whatever the granularity you got it, right? It has to route into this particular selection. And the name also suggests here, it is just to process this whole text into several checks, right? And also this rejects generation, and the other one is edit the distance recovery, which will go in a second. The first one you need to understand here is multi-granularity aware router. This component, as we spoke, this just analyzes this input text and determines the appropriate, the chunking granularity it's needed, and it sends the text to the most suitable chunking expert, because it underlying they may have multiple checkers, right? What it does, it will check it. If this particular text is suitable to the different chunker capability, it will send to that, and it will divide the text into several chunks, right? And we have a specialized meta chunkers, for example, fine granularity, medium granularity, coarse granularity, and extra large granularity. Based on the size of the text, specific particular meta chunker will handle those kind of text. And the last one, which we have to also speak about, this edit distance recovery algorithm. This is usually after dividing the text. It's the best, if I have to say in a simple words, it's a post-processing mechanism. Whenever you see some errors, it will try to correct it, right, in the chunking process by comparing the generated chunking rules with the original text, and it will make the necessary adjustments according to that, so that it won't have lacking of that mismeaning of that particular text. So it has to always check what is happening, and whatever the text that's been chunked, it has a real meaning or not. It will try to find that out. And there's also one of the key innovation which we have also here is regex generation. These two are in one block. This router selection and meta chunker is in one block. Input text analysis and granularity classification is one block. So I just want to also explain the each workflow here so you'll understand. This is the sequence of steps. Now, if we go to this particular regex guided chunking, rather whatever the model you have it, right? Instead of it generating this entire chunks of text, they MoC, the particular framework, guides the model to generate this regular expression, and it will identify the boundaries of chunk where exactly it has to separate it so that it won't miss that meaning, or to eradicate that confusion. You won't confuse a model without having the proper meaning of the text. So this helps us to divide the text into the proper boundaries. It will also add that expression to just have that start and end of the chunk with a special character replacing the content in between, right? So suppose where S is the start of that chunk and E is the end of the chunk, if you see here, right? And here whatever the R is a special character. This may contain like a long text, this may contain as a long text where you would know the start and end, right? Exactly, and it is separated by a special character. That's it. And the next one, after this model has been implemented, they have tested what we can understand from this results. Since we have seen in this particular chart, it has been outperformed in all of the scenarios on an average. And when you see here in this graph, the MoC, it has this particular experimental things where you can go with BLEU task and also rogue task. This is like a combined of a quality assurance tax, right? In out of this all this particular chunking methods, if you see the MoC, this performed somewhat better than the other chunking methods. If you see on this BLEU also and also this MoC, this is little bit better or way better than this other methods. This is just the representation of this particular values of the framework, how did it perform and its effectiveness. The one thing you need to see here is the computational cost. Its MoC came up to the in the middle where it's not so low or it's not so high or very high. It is in the medium based, right? And we have talked about this paper, how this is achieved and everything. The basic thing before the closing words is why this particular framework matters, right? This framework addresses a basic overlooked component in the rack system, as we are continuously repeating these things, saying that improving this text chunking. This will overall improve the performance of these LLM models to retrieve the better information which is used for the retrieval algorithms or the language learning models. This research also highlights the importance of optimizing the each component in the AI pipeline, rather than if you only focus on the generation or the retrieval, right? You may also have other small parts where you need to improve the performance significantly, right? And you have to also find the weakest link in the system, and you also need to work on it and research on it to have better optimized solutions, right? For developers or the researchers working with these rack systems, the MoC framework offers this particular approach to improve the system performance, right, better than other chunking strategies. So where you will get a relevant information from the documents, it can try to analyze and can produce the better output. So this is all this paper about. If you like this explanation or the concepts for it, please don't forget to share and subscribe. This will help me a lot. Thank you. Thank you so much.